Hello, Tom from everystepcalculus.com, everystepphysics.com from San Diego. This is a physics problem, as you can see. Now, if you can program like me these physics problems, which I can, and I have thousands of them, you look at this problem on your test, okay? What are you going to choose from my menu? All right. Number one, they don't give you this in the problem. Number one, this is an Atwood machine, okay? Universally stated in all physics books and everything else, Atwood machine. If it's a modified Atwood machine, it's this block number, mass number one, it goes up here on a table, on a ramp, angled, okay? But the first thing I always instruct the people that buy my programs, and I help them in physics or whatever, is when you look at a problem like this, you don't even need to read the problem. Take mass one and put it off to the side of your paper right away, okay? Because in a test you need to do this stuff quick. You can't be fooling around learning about stuff and trying to think about all this, what you've learned in the past or anything like that. M1 on the side of your paper equals kilograms, 5 kilograms. M2 equals 10 kilograms, okay? Now physics professors, and certainly in tests, like to trick you, as if physics wasn't hard enough, trying to remember, what formula are you going to put down for this right now? You tell me that. What formula are you going to put down for this problem, to solve this problem? I have no idea. Neither do I. And I programmed it and everything else, you know. But as far as writing down a program right now, as soon as I do my programs, I can write down the formula because it's good notes, and I've put it in my notes, and so now I know forever, not just for this test, forever. For all my grandkids, for whatever, partners, wives, whatever. So anyways, M2, now they might give you 10 feet. Okay, well I do the conversions for you and show you how to do the conversions too. I'll show you that in a second. Here's K equals 200 newtons per meter. Put that on the side of your paper. And now what are you going to use for this one? Here's 10 centimeters. Now this has to be converted to meters, which I'll do for you, and you have to do it too if you didn't have my programs. Everything has to be in meters, kilograms, etc. So they say it has fallen 10 centimeters. So what are you going to choose in my program for what you're going to put on the side of your paper? You're going to put displacement, D equals 10 centimeters, or what are you going to put, up or down? Vertical, whatever, okay? Well, here's the way I do it. M2 is a certain height off the ground, okay? Also notice in trajectories, like for instance when they give you throwing a ball off a building or something like that, they give you the building and of course they say it's 30 meters high, okay? So to me this is height, H, okay? And now they're saying that the block is going to be falling by 10 centimeters. That means it's falling in height, right? Okay, that's 10 centimeters. They could give you in this problem of how much 10 centimeters compress this spring, okay? That's a big deal in springs. Compressing it or stretching it, you know. That's called amplitude. And professors, wrongly I say, call that X. Well, you're in the y-axis right now. You're in the vertical axis, so that should be y, and I do that in my program. So remember that, okay? Anytime you're talking about anything vertical, if they're talking about distance in vertical, they're talking about y, okay? The reason we have to change it from height to that because there's a difference between compressing a spring and then something falling from the sky. So anyways, this is H. So you have H 10 centimeters. Now you got to convert that, which I'll do, and I'll show you that in a second here, okay? So we got an Atwood machine. Now you can go to Atwood machine in my programs, which I have. I'm gonna go to you put physics in there and go to my main menu. I'm at settings here, but if you scrolled up, you would, at the top of the alphabet, you'd come up to Atwood machine and Atwood machine modified to choose those, because other problems will involve those too. But we're gonna, anytime in my programs you see a spring, you're gonna go to springs, okay? Anytime you see something throwing a ball, or something with a ball, you're going to go to my ball program in my programs, okay? So you have to get used to what we call these things in my menu. So I'm saying it's springs. Spring calculations. And then, of course, there's a couple options here: vertical springs, horizontal springs, or angular springs, where a spring is being hit when it's sitting on a ramp or something, you know. But this is vertical. And so now we're going to choose. We went down here, all the way down here, mass, y. Here's y right here. That would be some sort of y-axis amount. Here's y and amplitude. Amplitude would be the amplitude which they give you in a problem, you know, and I'll take you through all these things, try to do it the best I can. We're going to choose M1, M2, K for the constant, and then H for the height. And here we have a Atwood machine with a block sitting on a spring, okay? We're going to enter the variables that you've put on the side of your paper. Mass 1 is equal to, you have to press alpha before you enter anything in my entry lines here. Alpha 5, and it's kilograms. They might have gave you grams, they might have gave you pounds, newtons, ounces, all have to be converted to kilograms. So I'm going to choose number 2. You can press the number before the option or scroll up to it. I'm going to press number 2. And the second mass, alpha 10, enter. I'm already at kilograms again. Spring constant, alpha 200. And that's Newton meters. Now they notice there's they trick you in problems. They give you newtons and centimeters, newtons and millimeters. Here's 1,000 newtons per meters. Here's feet per pound. They do all those kinds of things I've seen in tests, because I only program things from tests, because there's 10 million things to program if I didn't do that. Can't program everything. And all we want to do is pass physics and get the hell out of there. We don't care about learning about it or anything else, you know. And if you did, you'd become a physics teacher. Okay, so we're going to choose number 3, Newton meters. And the initial heights, we're going to choose alpha 10, and we choose centimeters, because that's what they give you here, centimeters. Need to convert that, so we're going to multiply it by 10. Okay, 0.1 meters. And we check to see if everything is correct, which it is. M1 5, M2 10, K is 200 newtons per meter. Height is 0.1 meters. Okay, so we could change it if it was wrong. Now we get into the formula. The first thing you do is write down the formula in your test. Formula is a square root of this quantity, 2 times M2 minus M1 times G, which is 9.81, times the height, minus the constant times the height squared, and then divided by M1 plus M2, that quantity, okay? All within the square root sign. So now we add the variables. Here's 2, 10 minus 5, here's 9.81, here's 0.1 for the height, here's 200, here's 0.1 squared, and divided by the quantity 5 plus 10, which is the summing of the two masses. Make sure you write this all on your paper so you look like a genius. Here's the square root of 9.81. That's what that comes up to as you do it, just like you would yourself if you were doing this. Here's the sum of the masses, etc., etc. Here's the answer, 0.72157 meters per second. Pretty neat, huh? Every step calculus, every step physics.com. Go to my site, buy my programs, and pass physics. I don't know how anybody passes physics without my programs. I mean, you got to have a cheat sheet. You got to have something. Anybody that can come up with these formulas simply because mass equals force times acceleration is unbelievable. So anyways, I help you too. You know, if you can call me or send me your tests, and I'll make sure they work and show you how to do it. I love it when people send me tests. I love to test my programs and do them quick. You know, be able to do them quick and help you. All I'm thinking about is not teaching you physics. I'm telling you how I can help you pass physics. Okay, so keep that in mind, and don't forget calculus either. Hey, have a good one. Good luck in your classes.